The central idea of this talk is why are these species where they are, why do they move, and what can we do to predict where they're going to be. And what I've got for you in this first slide is a distribution map of Palmar amaranth in North America. And you'll notice that there are a couple of states that aren't in green here. Those are just oversights. It's there too. Now, one of the things about Palmar amaranth is that it's been in the Midwest for quite a while, but it hasn't really caused much of a yield loss problem in crops. And so part of my emphasis in my research has been, is this thing going to move in a way that actually causes economic yield loss? So that hence the title is its looming threat to soybean production in Illinois. Okay, so Palmar amaranth, or Amaranthus palmari, is a dioecious form, and that means that it has both male and female plants. The females produce seed, the males produce pollen. And as a form, that means that it's broadleaf rather than a grass. It's a summer annual, so it completes its life cycle from seed to seed in 1 year, and it likes warm weather, so it emerges in the spring and completes its seed production sometime during the summer or early fall. One thing that really can make this tricky is that it has an extended germination period. And what that means is that the seeds of Palmar amaranth can emerge earlier than Waterhemp, and they can keep emerging throughout the growing season all the way up to that last couple of weeks in August. And this is a species that can complete its life cycle if push comes to shove in just a few weeks. So this seed can come up mid-August during lay-by, when the corn canopy or soybean canopy is beginning to senesce, and it can come up and complete its life cycle, produce its seeds in 3 weeks, 4 weeks. Now, Palmar amaranth that does that is not going to be a huge problem from a competition point of view, but it's certainly going to add seeds to the seed bank. How many seeds will a Palmar amaranth plant add? Well, a small plant, 10, 20 inches, a plant like that's going to add maybe 10,000 seeds. But once you start getting up into Christmas tree size, which is very possible in the gaps, then you're talking 500,000 seeds. These are very small seeds. They're about the size of a period at the end of the sentence. So they're tiny enough that these seeds are affected by static charges. And what that means is that they can adhere to grain seeds, like corn and soybean. And that means that they can be transported in feed grains. It's very difficult to clean these Palmar amaranth seeds out of grain just through air processing because of the static charges that build up. Of course, as you know from all the buzz, it's very competitive. So in the literature, we're talking anywhere 74 to 91% yield losses in corn and soybean. Now I've seen fields that have been completely obliterated, and we're talking more than 90%, we're talking full yield loss. So it's a species you have to take very seriously. A little later in the program, I'll be a little bit more precise on identification, but for now, just a few things. In these male and female plants, note that these inflorescences are quite long. We're talking feet rather than inches. They've got spikes on them, very, very prickly spikes. These seedlings of Palmar amaranth have pretty chubby leaves in comparison to Waterhemp. I'll show the comparison later. And the young seedlings grow in this rosette shape with seeds coming out off of the stem in all directions. Sometimes the leaves have a white or silver watermark, so it has kind of a poinsettia-like appearance. You should learn how to identify the species. This is going to be really important for you to know how to do. So at this core of where are weeds going to move and why do they move is the idea of the bioclimatic niche. And what I mean by this is the environment, both living and non-living, that shapes a weed's potential distribution. Okay, so in the non-living part of this, we've got this, we're calling here a hierarchy of resource factors, and they include a lot of spatial scales from the field, your individual field, all the way up to regional and global scales. And at these different scales, we're talking about soil type, so soil series, soil texture, topography, are we on a flat or sloping ground, how is the land being used, and what is the climate. Then we've got a whole list of biological factors that affect that potential distribution. So we've got dispersal. So what kinds of things can move Palmar amaranth seeds? So as I just said, grain is something that can move it. Contaminated machinery and cultivation equipment are things that can move it. Water. So all of the amaranths have floating seeds, and these seeds can be borne by rivers, flooding events. Birds can eat it and transport it as well. And then we've got disturbances. So within an agricultural field, obvious disturbances are tillage or addition of pulses of nutrients, like fertilizers. And then we have competition. So, plant may emerge. Where can it survive? If we've got a very competitive crop plant, that may keep it out, or at least reduce it. So those abiotic plus biotic factors add up to a realized distribution. But there's one more thing that we need in order to really have it be relevant to us, and that is, does the species cause economic levels of yield loss? And if it does, then we're talking about a damaged niche. And so that's what I'm trying to measure in my work, is where is the damaged niche of Palmar amaranth? This is based on work that was done by Andrew McDonald. So in order to get there, I want to look back a little bit. This is a map that was made by Jonathan Sauer, who was a botanist at UW-Madison back in the 50s. And he was really insightful. He drew a map of the distribution at the time of the weedy amaranths. And it included Waterhemp, Sandhill amaranth, Palmar amaranth, and then Amaranthus floridanus. And what he noticed was that some of those species were expanding their ranges, and some of those species weren't. And so the species that were expanding their ranges were Palmar amaranth and Waterhemp. The species that weren't were Sandhill and floridanus. And what he said that I thought was really very insightful was that the 10 dioecious species of Amaranthus, all originally pioneer plants of naturally disturbed habitats, have behaved quite differently during increasing human disturbance of their native continent, North America. Those at home in coastal marshes, beaches, and dunes, i.e. Amaranthus floridanus and the Sandhill amaranth, have remained static, while those from river floodplains and desert washes, Palmar and Waterhemp, have been expanding and diversifying in weeds in artificially open habitats. And so in both desert washes and rivers, what we have is repeated periodic disturbance events. So in river floodplain, you've got flood coming through, it loosens up the soil, it brings along silt and nutrients. In a desert wash, you have a similar situation. And these weeds are adapted to these flushes of nutrients and soil disturbances, that they can grow very rapidly and take over in that niche. Okay, so beginning bad news. Here's a photo from Larry Steckel in western Kentucky. That was a soybean field there. So this is the species that can take over and you can't see your crop. This is a case, a sad story of a farm down in Arkansas, actually, where Aaron's going right now. It was relayed to us by Dr. Jason Northwood at the University of Arkansas. And it was a large grower, about 8,000 acres. And he found what he thought was Palmar amaranth in his field and went to Jason to confirm it. He said, yeah, we've got it. And Jason said, you better get it out of there. And he said, well, I just don't have time. And he went 4 years later. He was not only overrun by it, he was out of business. This is something that made it impossible for him to produce his crops of corn, soybean, and cotton. It was bad enough and resistant enough that he could no longer cope with it. And so we've got 4 classes of resistances in Palmar amaranth. We've got glyphosate, we've got ALS, we've got DNA, and we've got the triazines. We've got arsenophyte, we've got the HPD as well. So they're not usually all together, but they're all potentially there. Okay, so on to the research. What is the damage niche of Palmar amaranth in soybeans in Illinois? So we've got this distribution map over here. That's the center of origin down there in the southwest in the Sonoran Desert region of the U.S. And we know that Palmar amaranth has expanded into soybean fields and commercial ag fields in the south and southeast and created a lot of damage. And the question was, will it invade northward as an economically important species? So what I did was to collect a bunch of populations, 8 populations of Palmar amaranth from around the south and Midwest, and grow them in 3 locations in southern, central, and northern Illinois, and let them compete with soybean and ask how much yield loss could we get. And so what I wanted to know was, A, will Palmar amaranth cause soybean yield loss in Illinois? B, are some genotypes of Palmar amaranth better suited to invade northward than others? So are genotypes of Palmar that were already adapted, let's say up to Lincoln, Nebraska, going to be better in Ravenna, Illinois, or DeKalb, Illinois? And then finally, is Palmar amaranth limited by climate, so it's just too cold in Illinois for it, or is it simply dispersal limited? Now, before I get on to the results, I want to make a point that I did not want to be the Johnny Appleseed of Palmar amaranth in Illinois. Okay, so I was doing this work, I didn't want to be the one distributing it. So we had to take some special steps in order to do this kind of work. First, rather than just planting seeds directly in the field, we pre-germinated them in petri dishes. We took those newly germinated seeds and then transplanted them into soil blocks here, 1 seed per soil block. You put them outside immediately, let them grow up to just 4 or 5 days, and then transplanted them into the field. So these seeds were germinated at the same time that soybean was planted, and then 5 days later, they went out in the field, 1 seed per soil block. And by doing that, we were not adding any kind of seed bank to the field. That's a really critical point of this kind of research. Once we transplanted them into the field, they were at a fairly low population density compared to that field. For example, that Larry Steckel sent a picture of. These are just in a half-meter space. And what I was looking for was a pretty conservative estimate of could this species cause yield loss. So this is a low infestation rate, and it also wasn't in there for the entire season because I had to remove it before it shed seed in the field. You can see that the rows were kept clean by the weeds, and they were kept clean by crews of students as well as technicians, postdocs. So I want to say a big thank you to the people who helped in this experiment. And you can see it getting bigger here, and then finally, when it reached reproductive maturity, as soon as it put out those inflorescences, that they were chopped 2 inches below the soil surface and removed from the field. And this is an important point for you to remember if you do any chopping of Palmar amaranth in your own field. This species can reroot from the stems. You can't just cut it and lay it down because it will reroot. It can reroot in the hottest, driest weather you can imagine, and it'll still come up again. So it has to be taken out. So anyway, this was to prevent seed return to the field. Okay, so here's the results. These bar graphs show 2 years of results, 2011 and 2012. The red bars are 2011, the blue bars are 2012. And along the x-axis, I've got the locations that the seed came from. The 3 panels refer to the 3 research sites of southern, central, and northern Illinois. And then on the y-axis here, we've got percent soybean yield loss of interference from Palmar amaranth. Now that may look pretty low to you, but remember, I had to remove these weeds after just when they put out that inflorescence. So in 2011, that was about 45 days after planting. In 2012, that was only 30 days after planting that. So not nearly a full season competition here. And so we're talking anywhere, from 5 to 40% soybean yield loss. So interestingly, seed source did not matter here. I just treated it as without any further information about where the seeds came from, just the state name. genotype was not a big issue. Location was, so there was less yield loss as you went further north, and different years were more or less suitable for Palmar amaranth interference with soybean. However, I was interested in taking a little closer look at this idea of seed source. So here on the x-axis, let me just explain this for you. I've got the latitude of the study site minus the latitude of the source. So if the value here is negative, that means that where the seed came from was further north than where it was grown. If it was positive, the seed came from somewhere further south. The larger yield losses came from genotypes that were more northerly adapted, and lower yield losses came from sources that were more southerly adapted. And it's not a very strong effect, but it is there. So there was some evolution and adaptation going on in these populations. Populations that invade from more nearby sources are likely to be more competitive with your crop. So what this boils down to is that, for the most part, the invasion of Palmar amaranth into Illinois is not a matter of if, but when, and it's seed limited, not climate limited. There's only a small impact of climate on this, and mostly it's just a matter of seed dispersal not happening at high enough levels yet, but it's out there, and clearly it's knocking at the door. And we see more and more of these events happening in recent years. Again, these are small seeds, 1 millimeter across, and very numerous. So this is a photo of a soybean field in south central Illinois this summer, unfortunately. And this is a photo in Kankakee. So it's here. It's not here as much as Waterhemp is here yet, but it's going to be. And so we have to prepare for it. Now in this picture, notice that it's invading from the field margin and coming in this way. So there might be a few different patterns that could explain that. One is there may have been an introduction of birds and weeds in the margin. They might have eaten it, deposited it there. Another possibility is that you've got an infection from a contaminated piece of machinery that started at the edge, left its seed node there, and then went further in. But at any rate, you can see that not only can it survive, but it can certainly outcompete soybean. This is a map from the science group at U of I, and they offer a service that you'd be well advised to take advantage of. If you've got a suspected population of Palmar amaranth in one of your fields, please, by all means, take those plants out, put them into a bag. The submission form is available online at the University of Illinois Weed Science website. They will make a positive ID of that plant using a rapid genetic test. The link for this form is in your booklets. And they'll also tell you what kind of herbicide resistance, if any, it has. And that can be a really critical management tool for you going forward, finding out what you can use to kill it, and whether if you do in fact have it. And so you can see that not only Palmar amaranth, but glyphosate-resistant Palmar amaranth is, 3/4 of the way up the state. So boiling these steps of what you can do down to a 3-letter acronym: prevention, reconnaissance, and eradication. Prevention is really the critical step right now. Learn how to identify the species, make sure you're using clean equipment. And that includes not only cultivation equipment, but combine harvesters. If you are custom leasing a combine harvester, make sure that the machine is clean. I had a few vacuum out combine harvesters from local retailers a few years back, and every single machine we found from 300 to a few thousand amaranth seeds. So you might want to assume that the machine is not clean. If you're buying in feed grains or meals to feed animals, you might want to test the sample and see if you've got some Palmar in there. If you've got an animal operation, you may want to consider composting your manure. 2 days at 140 Fahrenheit or more will kill the seeds. And if they're in windrows that are at least 1.5 meters high, that'll create the temperature, core temperature high enough to kill them. Reconnaissance. During multiple points in the season, get out there and be familiar with what the weed community in your field is. And because this species can emerge at multiple points, that means that even during late night, it would be worth getting out there. And then eradication. Eradication is not a particularly popular word in weed science, and it may not be 100% possible, but if you see, if it invades your field, starting with small populations, it's worth every penny to get out there, flag that patch, remove it, and follow up in successive years. When you're harvesting, make sure that a Palmar infested field is the last field that you harvest, and if you can, harvest around and avoid any heavily infested patches. And finally, you want to eliminate or limit emergence. And to do that, you're going to need some overlapping residual activity in your herbicides. Diphenyl ethers provide this, and depending upon what kind of resistances you have in your population of Palmar, you may have some other options. Okay. The final slide is an identification slide. And so here we've got a side-by-side comparison of Palmar, Amaranth, and Waterhemp. And these are the species that are most likely to confuse you in your field. That's the identification. So as I mentioned, these first leaves, not the seed leaves, but the first true leaves of Palmar Amaranth, you can see are a bit chubbier than those of Waterhemp. Waterhemp has these elongated lanceolate formation there. They both have this notched leaf tip, so that is not necessarily diagnostic. As you get to larger leaves, you'll notice that the petioles, or that little stem connecting the leaf to the larger stem, the petiole of Palmar Amaranth is much longer than the petiole of Waterhemp. Waterhemp, that petiole is shorter than the leaf is wide. In Palmar Amaranth, the petiole is longer than the leaf is wide. That's a really good one to identify. Also notice this rosette shape of the plant, that kind of poinsettia appearance compared to the sparser leaf structure of the Waterhemp plant. And then finally, look at the length of the inflorescences. If you're at the point where you can feel the difference, unfortunately it's probably too late. However, you'll know for next year. But even at that point, you can think about chopping. If you're going to remove, make sure you bag them. You don't want to be spreading the seed by shaking the plant as you walk into the field. Now, one point about managing the seed bank for the species, as with mare's tail, this is a fairly short-lived seed bank, about 4 years. If you send this down deep, it's going to make it a much longer-lived seed bank, and we're talking 15 to 20 years. So you could do that once, but then if you repeat with another deep tillage, you're going to bring that right back up. So under a worst-case scenario, you might send it very deep, but then you're going to have to let it lie for a while. If you can keep the seed near the surface in the fall, that's where most of the seed mortality factors are operating. You can deplete your seed bank, focus on limiting seed production, and staying on top of it, and I think you've got a good chance. Thanks very much.